Okay, so we should be recording and let's go. Okay, didn't I share my screen? Oh, I did. Oh, it is shared. Uh, so why is this here? Am am I sharing my screen? I think I am, right?
Yeah, you're sharing your screen.
Okay, you can see my screen good. Okay. Uh, okay, so let's do it. So let's start with uh the sample midterm, but that's usually a good place to start, I've found. Okay. And then on Sunday, we'll see how much time we have. But on Sunday, we could do the more, you know, going through all the folders and reviewing all that stuff. Okay, so I uploaded it here. I gave you a link, midterm review. Okay, so what we have here so far is just this document. Okay, this is a midterm I gave a while ago. Okay, question number one. Okay, don't worry about the numbers. It's actually what happened was I had three versions of the test. I so I did every third question. Okay, whatever it is, don't worry about the numbers. Okay, so these are the type of questions I'm going to ask. Okay, functional versus non-functional. What is the difference between them? Does anybody remember? Functional requirement versus non-functional.
Are you asking for the answer to the question or like specifically what's the
Well,
difference
you
between
have to, I mean, to answer A, B, C, D, or E, it helps if you know what the difference is,
uh
right? So in this case, actually, it doesn't make a difference, but in general, you should know the difference. So so the difference is that functional what refers to those are the things that the what? They specified, right? Non-functional are things that the customer wants, but they didn't specify. They're more, the reason why they didn't specify is because it's more of a, well, actually, they could, it's basically, they didn't specify it, but it's also usually a requirement which is very essential and spans multiple functional requirements. So the typical example is like performance, right? And no, this is non-functional. Like functional would be like the color of the background of the website, right? That would be functional. The font that you use, right? That's what the customer specified. The non-functional would be like that the reaction time, how fast it should be, how long it should take. You know, like if you do a search, how long does it take before the user will see results, stuff like that, right? So, another, I think a good example is like a non-functional requirement would be security, right? If somebody has a website that deals with social security numbers and I forget what's called PPI, personal something protected information, right? So if you have, I think it's called PPI, personal protected information. So like social security number, whatever. So that, or birthdays, that type of information would need a secure website, right? So even though they didn't say so, but you should be able, the non-functional requirement would be that it has to be secure because that's the law, right? The law is that you can't, you're responsible for. So in this question over here, prototype what is a prototype? It's not a requirement, right? And testing is not a requirement. Architecture not a requirement. Maintenance is not a requirement. What does maintenance mean, by the way, when referring to software? Software maintenance, what does that refer to?
the old version? Give it installed.
Well, well, let's say I'll give you an example. Let's say I say software is hard to maintain. What does that mean? Okay, right. So it's hard to make modifications, right? Maintain means to be able to change it, fix it up and stuff like that, right? So, okay, but over here in this case, it refers to requirements, right? Okay, that is an easy that's an easy question. Just have to right. They both refer to requirements, but just whether or not they're specified by the user. Okay, benefits of using cloud software. Okay, so number one, does everybody know what cloud software is? It's where there's not the software is installed, like for example, email, right? Email is well, it depends. Let's say Gmail. Gmail, there's no software in your computer in general, as far as I know, right? In Gmail, it's all on the cloud. So one of the benefits is no need for maintenance, meaning that I don't have to get my software upgraded because Google takes, they upgrade it on the cloud, right? Right. I should really say instead of no need for maintenance, no need for, um, no need to up, update, software, right? Okay. Um, okay, that would be number one. So that's true. Availability means it's in the cloud. So again, cloud software is greater availability, right? Because if one web server goes down, you could usually go to another one, right? Scalability, what does that mean? Do you remember what scalability means? If you say software is scalable, right? If I want to sell software and I want to say, you know what? Our software is scalable. Well, what am I saying? Right. In other words, that even though that there's can be more, even if you have, let's say, no, originally, let's say you're a small website, but let's say you become really popular and you grow, right? This, if it's scalable, that means that you could keep on adding more users and the software will still work, right? Usually with web software, that usually applies to web software because it means you could just add another web server, right? You just keep on adding web servers, and then so usually cloud software is more scalable than software that runs on a computer because you're limited, right, to the one device that you're on. And less staff required. That's also true because you don't have to install the software on everybody's machine, right? You don't have to, right? It's all taken care of by the company that's right. You don't have to configure Gmail for anybody, right? You don't need a help desk. Say, hey, my Gmail's not working. You say, oh, well, we're not in charge of Gmail. Go to Google, Google the problem, right? Submit a ticket to Google, right? Right. It's not our problem. When you buy software, then you need a help desk to configure the machines and all that stuff, right? So the answer would be E, all the above, right? They're all available. Let me just explain what availability means. Availability means um, uh, that we don't have to monitor the servers um, and up and monitor servers if they crash, right? That's not our problem, right? Because it's a problem, it's Google's problem to take care of Gmail, right? I don't have to worry about it, right? So that's good for a company, right? When a company doesn't have to worry about something, then then they could concentrate on their business, right? As opposed to making sure, everybody's machine is working properly and all that, right? Okay. So the answer would be E. Okay. The strategy pattern says that rather than use inheritance for different behaviors, what should we use? Composition. What's that called? there's a short four word description of that. Starts with an O. It's the second, what? Say again? It's the O in solid. Open, closed principle, right? That, um, right? I'm sorry. No, I'm sorry. No, it's not open, closed. Wait, the open, closed, uh, is, oh, no, I'm sorry. I'm sorry. It's not open, closed. It's the straight it places in here. No, actually, it's its own principle, right? That we prefer composition. We prefer composition instead of inheritance, right? Right. So strategy plan replaces inheritance with composition. Okay. And composition is another way of saying um, that we pass in the part that changes, the behavior that changes, we pass in. So for example, let's say we have software that charges that someone pays for that soft let's say I have a website that sells things. So the software will just charge a certain amount, and then we would pass in to that software different ways of paying. Like we would have a object that pays with a credit card, object pays with cash, object that pays with PayPal, etc. Right? So the object itself would not change, right? But rather it would pass in the parts that change, right? The different ways of paying will be passed into that object. But the object doesn't care how which one it's using, because whichever one it's using, it'll just call the same method, right? It'll just charge that object will take money from that object to pay for the merchandise. But the software doesn't care, um, what type of object it is, right? Okay. It could be any type of object that has a method for me to take money and give it to myself, to transfer money to me, right? That's all I care about. I don't care how it does it. Okay. If we look over here, we have a object called area, I'm sorry, a method called area and volume. And the difference between the two methods is that volume has three things, right? This is two-dimensional, so it's just height times width, and this is volume, it's height times width times depth, right? So first we get the area, which we got over here, and then we multiply it by the third parameter. Okay? So the question is there a better way to write the software? And notice what principle would tell us that there's a better way to write the software? Well, if we look at this code, what does this code do? It- yeah, it calculates area. What is this doing? Right, what? Right, it's doing the same thing as this. So what we really could do is we could actually, right, we could actually do, did I write it over here? Um, okay, so we're actually violating the dry principle because we really could do. Right, so right, because don't repeat yourself, right? And we are repeating ourselves. So really, the logic for calculating two dimensions we have up here. So really, code should, someone's coming. Okay, so really, the code should look like this, right? It should be something like um, reach, well, first let's calculate the area. So we have the area method from above. So let's do height and width, right? And then guess what? Now we only have two numbers. We could actually, oh, so we could do this, for example. Okay, time step. Yeah, that's one way. Yeah, we could actually, yeah. Or we could just call area twice, but that would be weird. Maybe that's not so clear, right? So to do something like this. Okay, so this would be the better way to do it, right? So we're for calculating the area, right? So this would be the uh how do I uh not you how would I change the color? Here, change that to red. Okay. Uh okay. Right. So this so really it should look like this, right? And the answer over here would be it violates, don't repeat yourself. Right? While we're here, what does Yagni mean? What does it stand for? Ria. Yeah, good, good. You aren't what? Right, need it. Right. You aren't going to need it. So what does that mean? In this case, like what? No. The answer to this one is dry. Don't be so. But Yagni means you aren't going to need it, meaning that if you have code that's never used, right? That code you should get rid of, right? In other words, people, like people like they keep old, clothes that they don't wear, they haven't worn in 10 years, they keep in their closet. So the same idea with code is you have code that's never being used and you just have it hanging inside your project, right? So Yagni says get rid of it. But what do you mean? I spent money on it. Well, the answer is because every time you keep old stuff around, right, there's a expense involved. What's the expense of keeping old stuff around? What? Okay, so one thing is because people don't realize, people look at the code, say, okay, I want to see what's going on. Let me see. Oh, there's a file here. I wonder what this does. And they don't realize it's never being used. Right? So if you have code that's not being used, you're wasting people's time because people think that this code is important and it's never used, right? So you should just delete it, right? Why have people waste their time looking at things that aren't being used, right? Or and the second reason is even more important, which is that if you have code as part of your project, you have to maintain it, meaning that if you change it, sometimes, even though it's not being used, but it has to compile because it's part of your project, right? So Yagni says, so then you're wasting time, or you're spending time keeping code that's not being used, and you're spending time to fix it, right? So Yagni says that just get rid of it, right? You might want to use it, you might need it. Nah, just get rid of it. Okay, that's Yagni. Uh, okay, it also refers to sometimes people. So this refers to a bunch of things. So number one, it refers to um, don't waste, don't waste people's time, right? Looking at um, unused code. And then two would be don't don't waste time, um, don't waste time fixing, maintaining unused code. I forgot what was the third thing I was going to say. Oh yeah, um, three is it's a form of Yagni, but it's not it's more like don't code for the future. In other words, let's say I think, you know what? I think I'm going to need this method in a week from now, right? Don't do that. Why? Because chances are in a week from now, what you think you're doing will probably change, right? So don't code for the future. That's also a form of Yagni, right? Uh, only code what you need today. Only code what is needed today. Okay. So that's okay. Dry, we said, means don't repeat yourself, which we understand, we just explained. Depends the inversion. What does that mean? What's the dependency inversion principle? Come on. It's a complicated name, but it really doesn't mean it's really a simple idea. That what it means that you should always what? You should always, when you're using a type for a parameter, you should always use the most general type, right? Because the more general the type is, then the less chance the code will have to be modified later on, right? It's right, like we said, the example with a cook, right? If you're advertising for a cook, right? And all I want the cook to do is make French toast. So if I say, well, I want a cook who went to French cooking class and who's a certain amount of certain height and speaks a certain language, I'm going to what I'm going to do is I'm restricting the amount of people available to be my cook, right? But if I say I just need somebody who knows anybody who knows how to make French toast, then I'm suddenly more, there's less, there's more people, a pool of people who could do that job, right? So I should be as general as possible because the more specific I am, then chances are I might have to change the code later on because I'm limiting myself. So I should just be as general as possible. That way, anybody anybody who could do that job should be, I should allow them to do it, right? So, okay, does that make sense? So for example, rather than use a list, you could use, I think, a collection, which is more general. And I think in more than use a collection, there was something else, right? So we want to be as general as possible, right? I think there was list, there was a collection, there was some other thing else, right? Um, right. So yeah, I'll show you that really quick. Um, into- come on. Yeah. So I'll just go to. I don't want your tips. Well, let's say I have over here. I have a list of, let's say, a list of um, bike factories. I don't care. Bicycle, whatever. So, okay. So let's say, for example, I have a method. Okay, let me go down a little bit. Let's say I have a method over here called fix bike, right? So void public void fix bike. Okay. And uh, or fixed bikes, okay? And I take a list of bikes, bicycles, okay? Oops, I did it. No, it should be bicycles. Okay, so I want to fix a bunch of bicycles and bicycles. Bicycle list. Okay, so this is my code, okay? So over here, I specified a list, right? Now, the Penzian version says, well, this is good, except but uh, Alt Enter. Come on. Um, it never works to Alt Enter. Did it work? Alt Enter. Import class. Okay, there we go. Okay, so let's look for a second. This 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 method only works with a list, right? What happens if we want to pass? Now, let's see, what does list inherit from? Oh, it actually inherits collection. So why should I limit my method to a list when I could put in a collection, right? Right? Now I could use even a more broad a type. And then I say, wait a second, why should I limit myself to a collection? Maybe for what I need, I could use iterable, right? And so I say, okay, I'll make it the most general possible called iterable. Now, if I look at iterable, unfortunately, that's it. There's no more, I can't be more general. So, but if all I need is to iterate, it knows if iterable has everything I need, like for example, let's say I need to, for every bicycle be in a bicycle list, I need to, I don't know, to be dot ride, right? Or let's say ride, let's call it ride bikes. Okay. So if all I need is just to go through the list and call the ride method, so I should use this type instead of a list. Because a list, right? Once I'm using a list, the collection won't work. I can't pass in a collection and I can't pass in a iterable, right? So why not? So the Penzian version says use the most general class available, right? Because you don't want to later on write list and then say, wait a second, I have a collection and then start modifying your methods, right? So when you start out, think about what you're doing and make it the most general method type that you could do. Okay? Does it make sense? Right? Never limit yourself if you don't have to, right? Always make your code as robust, right, as possible. Okay? So iterable will take more things than collection, and collection will take more things than list. Okay? Like where I work, for example, I use list, and then my boss, if he catches me, he'll yell, "Why are you using a list? Use the ice in in C sharp. There's something called an I set, I think. I think it's called I set. So he yells at me to use I set because of this reason. Because why limit yourself to something narrow when you could be more general? Okay. So that's the Penzian version. Why it's called the Penzian version, that'll take too much time to get into, but that's what the idea is. So the idea is always use the general, most general types that you can. Sometimes you can't, right? But, right. Like if I'm using a double, I can't, I don't think there's anything I could have used instead of a double. Maybe, you know, I'm stuck with that. But like, but like for, um, yeah, or a string, I can't really use, probably I can't use anything else. But sometimes you can. It depends on the, you know, you know, uh, depends on what you need, right? If what you need is inside the base class, right, use that instead, right? Okay, list cup substitution. What does that mean? In a brief summary, what does that mean? No, that's strategy. But that's a good guess though, because of substitution. Right. No, yeah. Okay, so list substitution means that if you have code that works with a parent object, right, you should be able to substitute the child object from that parent and because it will work, right? In other words, going back over here, let's say I have a, for example, if I have over here, for example, let's look over here. Uh, let's say I have, um, let's say, I'll do real fast. Let's say I have um, uh, a, uh, I don't know, a road bike. And road bike is public and implements bicycle. So in this example, um, uh, riding road bike. Okay, okay. So for this example over here, like over here, when I call ride bikes, right? I could pass it a I could pass it not just anything that implements bicycle, right? Right. So okay. So okay. Oh wait, let me just do one more just to make it even clearer. Let's say I do uh fancy road bike and fancy road bike um extends or inherits from road bike, right? So so over here I shouldn't Um, I shouldn't have, if I have the code over here that's, what is it, void ride? Pub- So riding fancy road bike. Okay, so let's say I have code over here, right? There, let's say have a code called um, ride ride bike, and ride bike takes um, a road bike as a parameter. Okay. Um, and let's say it just calls um, and it calls bike dot ride, right? Now, if I would, if I'm over here, right, and I could say like this, I could say, I'll make this static. Okay, so over here, I could say something like ride bike, and I pass in a road bike, right? Oops, a road bike. Okay. And if I do this, right, it's what's it going to say? It's going to, oh, I didn't, yeah, it's going to print riding, road bike, right? That's my output. Now, but I could also pass in a child of road bike called fancy road bike, right? Right? And now if I run it, it says riding like a fancy road bike. So I'm getting different output, right? When I use the child of the of road bike, right? Over here's the parent and here's the child. When I use the parent, I get this output. When I use the child for the same method, right? Ride bike, I'm getting two different outputs, right? So Liskov says that is bad. She says that if the parent gives one result, which is riding road bike, then the child should not should not give a different output, right? And the reason is because since this method, um, right, doesn't know the difference between road bike and fancy road bike, in other words, when someone runs this method, they're expecting the same thing to happen, whatever you pass into it, right? But instead, what's happening is two different things, depending on whether you do the parent or the child. Okay, so she says that that's a problem. Okay, that's Liska substitution. So basically, it means that when you substitute a child for the parent, it's giving a different result, which he says is no good because it's expected that this should always do the same thing, right? You expect that the children of the parent should give the same result as the parent. You don't want all of a sudden different things happening, right, without realizing it. Okay? So that's her I happen to think that yeah, that okay, whatever. That's what she says. You know, you might want to think about it and argue and say, well, maybe she's wrong. Maybe a child could give different results. But she's basically saying is that since this code is expected, when this code was written, it was expecting this output, riding road bike. So then when you give it a different output, right? So then you could break this ride bike method, right? So she's saying that basically since it's written for road bike and road bike gives a specific output, you shouldn't change that output because then you might break the code, right? In this case, it doesn't break anything, right? But in other code, it might break it, right? Because the code is written expecting this, and now it's getting this, okay? So, and that might break a program, okay? Right? So, because it was written with this object in mind, okay? Now, I think there's a way you could do that, by the way, to get or whatever. You could think you have to think about a little bit because it's not so obvious that's really an issue. But she became famous because she has it named after her. Liskov is a lady, Barbara Liskov, so she became famous for this idea. Okay. She's the only one I think that has a object-oriented principle named after them. I don't think there are any other ones, any other people who have something named after them. Okay. Um, so let's go through this. So we're not just doing the test, we're like going through all the ideas. What is single responsibility principle? This is the S in solid. What does that mean? Well, okay, every function, right, every object, let's say, right, should have one, or method, right, should have, right, so, in other words, um, every object and method should have just one purpose, right? And what's the reason for that? Why should only have one purpose? Oh, number one, because what does that mean, maintenance?
It has more than one purpose, it's gonna be hard to like read and understand.
Okay, so it's easier to understand, right? Okay, what's another right, it's basically two is basically similar to that, which is that oh wait a second. Oh boy. I have to let these people sorry. Sorry, I just noticed that. Okay. Sorry about that. Okay. So the corollary to that would be that it's if you're doing less things, then there's changing in changing something in changing that object or method will can only break one thing, right? In other words, you can't accidentally fix one thing and then break the other, right? Because you're only doing one thing. Very simple idea, but it's a powerful idea, right? If you mess around with a computer CPU, you can mess up lots of things, right? But if you're working on the keyboard and you just take off a key and put it back on, the only thing you can mess up is that key, right? So the chances of messing up, I mean, of messing up something else are zero, right? You can only mess up one thing. But if you're, pulling out wires and, and you don't know what you're doing, right? You could break a lot of things, right? A lot of things could be, you know, okay. Uh, which of the following are true? More than one can be true. Okay. Okay. So over here we have a class object called medical record. Okay. Uh, it has a, inside of the medical record, there's a database object, right? And then the way this medical record, the database object is set is through the constructor, right? When we create a medical record, we pass in the database, okay? So that's our code. Pretty simple, right? You agree it's simple? Okay, I mean, you could disagree and say it's complicated, but I don't know how to get rid of this on top. Oh, there we go. Okay, so let's look at the statements and see which are true and which are not. So statement number one says medical record and database is a relationship. Is that true? No, right? Why not? Is a with what? Say again? Right, so it's not inherited, right? Is a means it inherits, it's not inheriting, right? Okay, but what is this called when it's inside of it? It composes it, right? Composition. Okay, Right, so B is true. Medical record composes the database object. Very good. Database is encapsulated. Is that true? What does that mean even, that's encapsulated? It's protected, right? Encapsulate means to protect it. Is database protected? It's public, right? Okay. Well, you're good. Okay, medical record is dependent on database. Is that true? Is there dependency between medical record and database? What? Yes. Yeah, because it needs it, right? If this object isn't in the project, it won't compile, right? So it needs it, right? You can't compile medical record unless you have database object there also, right? So it's dependent. Medical record and database have a has a relationship, right? That is true, right? That's composition, right? That's their relationship, right? Medical record has a database object, right? Okay. By the way, what about the database object? Oh, we don't know. We don't know. Um, but we could say that database is not dependent on medical record, right? That we know because otherwise it would be circular, right? You couldn't have database dependent on medical record because then it would be it would not compile because it would be circular logic, I think, right? So I'm pretty sure database cannot rely on medical record. Though we could try in the compiler one day. Okay, I'm pretty sure it won't work, right? Because what comes first? Which of these do not involve incremental development? Remember, we said on Tuesday, I know we did it kind of fast, we said that many things are, we're basically considering everything incremental, right? Okay, so what were the things we said are incremental? Extreme programming, is that incremental? Yep, everything in chapter three. So agile, is that chapter three? Yes. That's also incremental. Scrum, that's also chapter three. Software reuse, is that? No. That's the right. So that's the answer. Iterative development, that is incremental, right? Iterative means that you do a little bit at a time and you repeat yourself, right? So all these things are considered to be incremental. Which design pattern uses this principle? Open for extension, closed for modification. Okay, so which design pattern um, will, when you could add, well, first of all, what does it mean open for extension, closed for modification?
Can change the code, but you can write more methods.
The way you change the code is by
And more.
adding more rather than modifying, right? Right, you're allowed, right. You always have to write more code, right? Or you wouldn't be we would be out of work, right? But the point is, how do you do it? The best way to do it is the open close principle where you're adding code and instead of changing existing code, right? Because then if you don't change existing code, then you only have to test the new code, right? You don't have to worry about breaking previous code, right? So, so which design patterns show that? Well, the observer pattern does that, right? Because you could create more different types of observers without, remember with the stock market, we could create different observers without modifying the stock market, right? We could just, add them as observers, remove them as observers, right? And the stock market doesn't have to be changed. We didn't do the state pattern, so uh, don't worry, it's not going to be on the test. So I'll just delete that. Okay. Um, well, I'll just say not on test because um, I'll just say. We didn't recover this. We didn't, cover this design pattern. Okay, the strategy pattern, does that, remember like with the ducks, right? We said you could pass in different ways to fly, right? So that's also open for extension, close for modification, right? Because we weren't changing the duck, but rather the behaviors that we passed into duck, we kept adding different behaviors, right? So that also is open for extension, close for modification, right? And all the above is whatever, whatever. Just ignore these two because you don't. It the answer is basically all the above, but um, the answer is let's just say the answer is really just one and three and two, but we didn't do two, so just one and three. Okay, so it would have been all the above. Okay, okay, so uh, okay, got it. Uh, 23. Um, This is just from the first chapter. Challenges facing software engineers. So new technologies, yeah. Reduced delivery times, yeah. Um, why are delivery times being reduced? Because why is there pressure to come out with software quicker than it used to be? Well, right. Well, because there's global competition now, right? If you have your software in the cloud, right, you're competing with everybody else in the cloud, right? So if you have software, everybody, it's a global market nowadays, right? So now you're competing, it's not like with a car where Trump could put 100% tariff on something, right? And stop it, right? Now with software, it's in the cloud, it doesn't make where it's made, who made it, you could use it, right? I don't think there's any tariff on software, right? There's no one blocking using software made in any country, right? Right? It's global competition. There's somebody in, in Russia, in China, anywhere in the world, and uh, if they have a good website, they're you know they're they're in business, right? I just noticed it's not actually cloud software, but I know like at work we use and it became very popular. Is a husband, I think it's a husband and wife. They're the only two programmers, and they have software that everybody uses. Pretty amazing, and they charge for it also. They made a whole company out of just a man and a husband and his wife. So it's pretty cool. So, so even though they live in, so they're competing like with a lot of other people. I think there's like 8 competitors for what they do. But yeah, I'll show you the software. It's cool. I mean, whatever. It's not. If you use Git, or if you ever use Git, it works with Git. They have a GUI that does it. So a lot of people where I work, people use it. But there's free alternatives, which I haven't looked at. So developing trustworthy software, that's obviously very important nowadays because basically, I should say new challenges, right? Because nowadays, there's a lot of, you know, software that could be, you know, people breaking in and, stuff like that, right? Stealing your code, in there, all the information you have, right? Global, and okay, and we just said global competition, and all the above. The answer would be all the above, right? So they're all things, because of, because of uh, uh, bad people on the internet. Okay, so you have to So you have to worry about all these issues. It used to be that your software just ran on the computer, and if anything, you needed maybe after a while you needed like antivirus software on your computer, but that was it. It wasn't like, you know, like like anybody in the world could attack any cloud software, right? They could try to break in and steal their data, right? So so you have, you know, potentially on how many people live in the world, 8 billion people. Any of them could try to attack your website and do something to you, right? So it's very difficult. Okay, so over here is uh, okay. Well, basically, forget. I'm not going to go through this one because it'll take too long. But um, what am I doing over here? I have basically two lists, one of French banks, Spanish banks, and, and when I borrow from banks, I go through each bank, and each list of banks, and I borrow from them. What's wrong with this code? What does this code remind you of? Where do we have the same issue? What, say again? Well, we're not really, no, we're not really repeating ourselves. We're just, because they're different types of bank, right? These are Bank of France, Bank of Spain. They're different types of banks, lists of different, yeah. Yeah, and now we had this, well, the observer pattern, right? We have different types of observers, right? But we put them all together in one list, right? Because they all implemented um, a interface, right? Now here we have interface called bank. So rather than have a list of Bank of France and a list of a Bank of Spain, we should really have what? One list of bank, right? Which will which will work for both Bank of Spain and Bank of France, right? Right. So we should try to, since they both have this borrow method, right? So then, we should be able to combine them in one list, right? And then every time we add a different type of bank, we don't have to create a new list every time, right? We could just add it to the bank list, right? Right? The list of just one list, right? We just have bank, right? Because bank is the interface that all the banks implement. Okay? So that's basically the um, just quickly going through financial institutions is using inheritance. You see inheritance here? Nope. The financial should use composition. Is that true? No, it is using composition, right? So that's false. Bank of France should use extends rather than implements. No, we don't want to use inheritance, right? So that's false. Financial institutions is closed for modification. No, it's not closed for modification because if we add a new type of bank, we have to modify this code, right? We have to add a new list, and then we have to update this method over here to include the new list. Or if we remove a list of banks, right, then we have to update the code, right? So it's not closed for modification. It should use observer pattern. So E would be the answer. 5 would be the answer, right? It should use observer pattern and have a list not based on the concrete type, but based on the interface type. Okay? So that would be the observer pattern. Okay? And then we don't have to modify the code if we have a new bank or if we remove a bank. Okay. Regarding the singleton pattern, the following is true. You remember singleton? Okay. So the singleton has two forms. Does anybody remember what the two forms are of the singleton? It's not, I don't know if it's part of this question, but do you remember the two forms of singleton? Well, what does singleton mean, by the way? What's the meaning of singleton? So the answer is singleton means what? Single, meaning that there's only going to be one object, meaning either one counter, like one ID, for counting IDs, or one database connection, right? There's only be one of something, right? Many programs need to have only one of them, right? So usually when you have one of something, it's a global, right? But we said that just having a global is dangerous because anybody could mess it up, right? So singleton is we have a global, but we have a code to protect it, right? So it can't be easily messed up. Okay? So that's the idea of singleton. So singleton says we only have one type of object, right? We only have one of an object, but we're going to protect it. So that's what a global is. Global is if you only have one throughout the program, and like we could have a global object, let's say ID, could be used anywhere in the program, except it can also be modified anywhere in the program, right? So and then it's really hard to follow. So what a singleton pattern says is you can have your global, but we're going to protect it from getting messed up. Okay? We're going to surround it with code that's going to protect it. Okay? Okay, so that's the basic idea of singleton. And maybe I'll just show you real fast if I have it somewhere. Let's say recent projects. We have that. Open recent. Oh, here we do. Singleton. Is this the right one? No, I think this is not what we wanted. Uh, do we have singleton here? Observer. Oh, here we are. Okay. So for example, in get ID, right, we have a method which is going to give us the next ID. Okay? So we're hiding the ID by making it private, but it's a global, even though it's global, it's private to this method, and the only method that could change it is get next, right? Okay? And if we want to reset it, that could also change it. Okay? So there's only two methods that can modify ID. And since it's static, it is a global, right? So every time we use it, right, it's going to every time we use it over here, right, it's going to give us a new ID, right? Okay. So that's okay. So this is one type of of singleton. So this type is when is ID created? Do you have to create this object to create ID? No, why not? It's global, right? Right, static, it's global. So when is ID created? When the program loads into memory, when the program gets loaded, it automatically, part of the loading process is that all the globals are created when it loads, right? Right? The memory is allocated and all that stuff, right? Okay. There's another type of singleton called over here, which where for whatever reason we don't want it. We can't either. We don't want to, or we can't create it when the program loads. So instead, When do we create it? The first time we need it, right? First time we call this method called getDBConnection, it's going to check and see if it hasn't been created, and then it's going to create it, but only the first time, right? Because the next time this will not be null, right? It'll have a value, right? So the first time we call it is when it gets created, okay? So that's the second form, but we will only have one database connection, okay? Right? We're never going to have two of them because because every time we call getDBConnection, it's always going to check to see if there's already one created. If there is not, it's going to create one. And once there's one that's created, it's always going to return the same connection. Okay? So those are the two ways to do it. One is like loads that it creates the object when the program loads. And the second way is that it creates the object the first time it's needed, okay? For whatever reason, you can have different reasons. Either you can't create it when it gets loaded because you don't know you don't have enough information to create the connection, or it could be that if everything gets created when the program loads, it's going to be too slow. So you rather wait till you need it to create it. So because you don't want the program to load slowly, because then the customer thinks it's something wrong with the program. So whatever reason, you want to have a late creation. Okay, so let's go back over here to our question. So regarding single the following is true. Only one instance of an object. Is that true? Yep. Okay, protects access to global object. Is that true? Okay. Object can be created first time it is used, right? We said that is one of the forms of singleton that we wait till we need it, and then when we need it, it gets created. Object can be created when program starts at runtime. That's the second way, right? All the above, right? So the answer would be all the above. Okay. Um, again, we haven't done 35. We're going to skip that. Okay. The following is true about incremental development. Remember, incremental means everything. Scrum, right? Don't worry, don't, focus on the word incremental, focus on everything like that deals with, think Scrum. Okay. Think Scrum, Agile, whatever. It's all the same. Okay. So what is true about incremental development? Customer involvement is not recommended. Is that true or false? False, right? All requirements, let me just fix that. All requirements are determined before coding. Is that true or false? False, right? Because each iteration, we decide what our requirements are, right? We go to the product, let's say for Scrum, we go to the product backlog, right? And we pick which ones we're going to do, and maybe we create some more, right? So we don't know when we start the project exactly what we're going to do, right? We have an idea where we're headed, but we can't swear, this is what, like waterfall, you could say, this is what, sorry, waterfall, you could say, this is what we're going to do. Here are the requirements, pay us for this. And we guarantee we're going to do this, right? With incremental, you can't do that. You could say, this is what we're going to do, exactly what we're going to do. Well, it's probably going to change as we go, right? So we can't promise you exactly what's going to be done because we don't know. Okay. Three, it's easy to make modifications. It's sort of easy, right? It's not really easy, but sort of easy. Sort of easy. Yeah, it's easier than waterfall. That's really what I mean, right? And why? Because since we're getting new requirements, like waterfall, we want to stick with the original requirements. But with incremental, we're getting new requirements every cycle, so we could change it a little bit, right? Because we're constantly doing requirements, coding and testing. So if the last iteration, we didn't like what we did, we could change some of the requirements and do it a little bit differently, right? It's not a horrible thing like in waterfall. What do you mean? This is it. We're not changing. Okay. Um, a code does not need refactoring. Is that true or false? False, right? Because what is refactoring? When you keep changing code, or adding to code, by definition, when you add to code, you have to modify it usually, right? Normally, if you keep on doing a little bit at a time, you're always, modifying the code before to use the new stuff. So basically, the code is always changing, so you always have to refactor, right? Refactor means to take the code and change the structure so it's clean, right? It means clean up your code, basically, right? Right. Like if I clean up my desk, I don't have any more, I don't have anything different on my desk. It's just organized, right? I have the same things I had before. Maybe if I organized it, I threw some things out. But in general, right, just because I am organized doesn't, right? If you if you throw all your clothes in the suitcase, or if you put them neatly, you still have the same amount of clothes. It's more easier to see how many pairs of socks you have if you didn't just throw them in to the suitcase, right? You could easily say, "Oh, here are my socks." I could see how many socks I packed. But if you just throw all your clothes in, it's a big mess, right? You have to pull all your clothes, count the socks in your suitcase. So same thing with code. If it's not organized, it's going to be very difficult to do things, right? To add, to make changes. So, um, so, so code. So when you're doing incremental, the code will need a lot of fixing up. So the only testing done is unit testing. Is that true or false? False, because we said there's two types of testing, right? At least, right? Unit testing is done by who? The who? The developer, right? And then there's another, when we say testing, we say in Scrum, we say there's requirements, coding, and testing. The testing, we mean with that testing refers to the testing group, right? There's a there's a person or people designated to be testers who are not developers, right? Right. So some people are testing and some people are developing, but there, but there the so there's two types of tests, right? There's a test written by the non-programmers and the test written by the programmers. So the programmers just test the little parts of their code, and the other testers they just do, they test the whole thing, right? Like where I work, we have one guy who's dedicated. He's like the testing department. Uh, well, actually, he's in charge of creating automated tests, but there are other people who test the code. In other words, usually what happens is somebody writes up the requirements, and the person who writes up the requirements is responsible to test their code. And then there's another guy who writes automated tests. Okay, so we have like two layers of testing besides the unit testing, right? Which, be honest with you, most of the people where I work don't write it, don't create it, because there's no one looking over our shoulders yelling at us to do it, so we don't do it. So we should, though. I mean, you know, sometimes people write unit testing just to check out. Yeah, sometimes people do it. I shouldn't say never, but not too frequently, right? Which isn't, which is not good. Okay, over here, something is missing. This is referring to chapter 1. I have specification, which is another word for requirements, development, which is another word for programming, evolution is another word for what? Maintenance, right? Or 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 making a new version of the software, right? So what am I missing over here? Well, the answer could be more than one thing. I'm missing a couple of things. Testing, right? Left out testing, deployment, right? Right. I'm not sure what else I left out, but definitely those two, right? Deployment and testing. Testing. I think I had in mind testing, but yeah, I probably should have put deployment, and then the thing that would be missing would be the testing, right? That would be okay. That'd be a better way of doing it, right? So the answer would be testing. Okay. Okay. This is going back to um, chapter 2, where we went through, remember, how many different ways of developing software are there? How many different process models are there? We covered how many? Waterfall, incremental, and reuse, right? So we said that each one has a specific type of software that it's good for, right? So for example, waterfall, what type of software is waterfall good for?
Medical.
No, I'm saying general. Like, why would you want to use waterfall where everything is defined up front and then we don't change it, right? What type of software, why would we want to do it? It's kind of very difficult to think of everything before you do it, right? But sometimes it's a good idea. Could anybody think of a reason for that? What type of software would that, like you said, medical, what's special about medical that would require waterfall?
Requirements are strict.
Well, no, well, in a way, yeah, you're close. It's basically it's expensive to make changes, right? So, for example, medical software, right, is is regulated by the government, right? So when every time you change the software, right, then you have to have somebody come from the government, FDA, and they're going to review the device, right? Or they may have somebody check it, right? Check it to make sure that it won't kill anybody, right? So therefore, you don't want to make changes because you want to limit the amount of changes because it's very expensive to make a change. So basically, you use waterfall when it's expensive to make a change. So examples of software that's expensive to change is regulated software, which would be, let's say, medical software or software that flies airplanes, right? Or or also um, we have a large project. You have a lot of different groups working together. So then if one group changes, you can't change the requirements because that affects all the other groups, right? So it's too hard to, you can't have each group changing requirements on their own and then because it affects everybody else, right? For example, people working on the engine software, if they say, okay, we're going to let the engine fly 10% faster than we originally thought, well, then that's going to affect the other groups that they're designing the wing, right? The wing software or the whatever software, right? So it's too difficult when you have too large of a project to make to start changing requirements in the middle, right? Or another example would be embedded software, software that works with hardware. So then sometimes again, I'm not an expert on embedded software, but software that works embedded, meaning it works like with a chip, it runs on a chip like a refrigerator, it has embedded software, or everything now is smart. So like a smart light bulb, whatever, all the stuff that uses software, or it has a chip and uses software, it's expensive. Whenever you change the software, you might have to modify the hardware, which is very expensive, right? Right, because you're not just changing software, you're changing hardware, which might be very expensive. So I don't know that much about embedded software, but that's what the book said. So okay, so refrigerated software is embedded software, and medical software is regulated software. So both of these should use which model? Waterfall, right? Because one's embedded, so it's hard to change, expensive to change, and medical is also expensive to change for different reasons, right? Airplane software is regulated, medical software is regulated. So that's also the same. Game software, there's no regulation on a game software, as far as I know. So, and medical software. So these two are going to right, game software, right? If it crashes, no one cares. I mean, very few people care, right? They'll just start over again, right? Right. There's a there's a there's there used to be a TV show where I saw it on YouTube, a rerun where somebody got like a high score on a game. And it used to be like these games were like in the store, what I'm talking about, like a video game in the store. This guy got the highest score, and he wanted to he wanted, to remember like he had the high score. So he wanted to have like a long electric plug. And he wanted to take the machine and bring it into his house because because once he unplugged it, he would lose the highest score. Yeah. Yeah, it's kind of funny. So he had this whole plan how to get to save that he was the highest score. Yeah. Anyhow, but game software could crash. So you would probably use incremental, right? And medical, on the other hand, is waterfall. So these two are different, right? Right. Scalable software. Okay, wait a second. I don't know why that happened. Uh, and software that can handle unlimited users. Are they different? No, that's actually the definition of scalable is software that can handle unlimited users, right? That actually that was a trick question. Yeah, they're exactly the same. So whatever one does, the other one does. Okay. Your website using Amazon checkout, right? So in other words, I have my own website, but I'm using Amazon checkout. I don't know if I could. I've seen that sometimes. It says checkout with Amazon. So I guess you could use Amazon or using third-party graphics library for your game software. So in both cases, what am I doing? Reusing. So they're both the same. So the answer would be 3, right? Those are the only ones that are different, right? Like I don't even know what 4 is, but whatever it is, it's the same for both because they are the same. Okay. Oh boy. You want to give a presentation?
Can do it next time.
Uh, okay. You don't mind?
Yeah.
It would be after the midterm. Okay.
Yeah.
Okay. Thank you. Okay. Okay. What is this is also like chapter 1 stuff. Feasibility means what again? Is it practical, right? Meaning that do I have the as a developer, do I know how to do it? Right? Like I personally am not really good at web software. I've never really done any projects, besides playing around. And yeah, I haven't done any, for work, I haven't done anything web-based. On my own, I've done stuff, but I'm not really good at it. So someone asked me to write a website that's using some, I don't know. I would, yeah, I would be honest. Hopefully I'll be honest and say that, go to someone else, you know. Um, I don't, or feasibility means that someone wants you to do it. You say, well, do you realize it's going to be very expensive because a programmer costs at least 100,000 a year, with benefits and all that. It's going to cost a lot of money, for just for one developer. And then there's going to be testing and all that stuff. So do you realize how expensive it's going to be, right? So you want to like let people know. So that's feasibility. Requirements, you know what those are. Design, you know what that is. Development, you know what that is, and testing. So what is the order? What steps should they be performed? What?
It's already ignored.
Oh, very good. So it's A, B, C, D, and E. Okay. Right, there was another four options. Okay, very good. So it's already in the right one. Let me just move this down so it's in the same together. Okay, it's already in the right. It's A, B, C, D. Any order is okay. Okay, I like that one. Uh, it's very hard to think of wrong answers that sound correct, you know? Um, it's not, multiple choice is very hard to do because, first of all, it's hard to think of wrong answers that sound correct. And also, it's hard to, sometimes a different answers could be correct. So it's hard to find where, like five different answers where only one of them is 100% correct and the other four are definitely wrong, but they could still fool you. So I don't know. So multiple choice is much harder than it looks. It's easier maybe to grade, but it's harder to create. The following can possibly be reused for many different projects. So could a system be reused, a whole system? Could an object be reused? Could a component be reused? A web service be reused? So the answer would be all the above. Okay. Okay, so all that stuff could be used. Over here, what am I doing here? I'll forget about that. You don't have to. Yeah, forget about this. This is only like if you don't have to know that. Okay. Um, okay, so uh okay, I'll just mark this in yellow if I could find the highlight color. So you don't have to worry about it. I'll make it. I have to go all the way to the top. And where's the highlight color? This? Okay. Okay, so you don't have to do that. Okay, then I have to go back down. How do I get rid of that? Okay. Okay, well, it's considering that it is actually a very well written thing, considering it's running on in JavaScript, I assume, right? Right, this is all written in JavaScript. It's really well, a lot of work went into this. And not only that, it always saves everything you do right away, right? Um, okay, which process model is um, is represented by this diagram? Before we do it, let's go over this. So waterfall, we know what that is, right? What is the V model? Did I make it up? Or do we actually cover it in class? So what is it? It what is it similar to?
Also to waterfall model, you could go back.
Right. It's a modified waterfall, right? it's basically a waterfall model with with the testing created as you were going down the waterfall, you created tests at the same time. So when you finished the waterfall, you went back and used all the tests that you wrote, right, during the waterfall part of it, right? So V model is the same as waterfall. Incremental is incremental. Reuse is reuse. Step model I just made up. Okay. So this is showing what? Basically incremental, right? Oh, I mentioned that this is wrong. It's a bad image, right? Because over here they're putting the testing before the implementation. Implementation is the coding, so that should go before the testing. Uh, okay, I should whatever. It's a wrong image, but but it shows you the idea that you build one, build two, build three, and you keep on repeating the same thing over and over again, right? Okay, it's a little bit different than the one than the picture in our book. Um, okay, the image below. Okay, what does this represent? If you see this in a model, UML diagram, it's a hollow arrow pointing up. Yeah,
Is it like the child of the parent?
inheritance, right. Right, so that would be inheritance. Okay. In class, the image below, okay, well, this is basically okay, forget about this. It's too complicated. But basically, the duck was the strategy pattern, remember? We did the duck where we passed in different behaviors. So that was the strategy. So forget about the image, whatever it is, um, the program below shows which design pattern. So it shows the they were passed. You know what? Forget about this. It's just too complicated. Okay. Okay, 68. Which class below is the best way to uh, to design code? So, okay, let's look at this code. So over here, accounting is is inheriting from database. Is that a good idea? Well, no, right? Because it's using inheritance. We rather, if accounting needs to use a database, we rather it get passed into accounting rather than inheriting from accounting, right? Right. So we don't like inheritance, right? In general, right? Okay. Accounting implements iDatabase. Also, that doesn't really make sense, right? Because accounting is accounting and database is database. Why would we want accounting to implement the methods in an interface, right? That has nothing to do with accounting, right? It doesn't make any sense. Um, okay, over here we have a um, a accounting class with a database of type I database, right? And over here we have the same thing, except instead of I database, it's database. And let's forget about line 5. It's too complicated to explain. Okay, so we know these two are no good, right? Because they don't make sense, right? Why would accounting, which is has nothing to do with database, why would it? It's not. Why would that be a child of a database, right? That's not how you use database, right? Or this would also not make sense that accounting should do database methods, right? Rather, accounting should have inside of it a reference to a database, right? Object, right? Right? So these both are, so 3 and 4 are both good, but which one is better, 3 or 4? 4 has, okay, now database is um, oh, I didn't say that. I should, let me just, I should actually show that. Um, um, I should have, I should have public, um, public class, database. Um, okay, this is better. Okay, so, okay, so now which is better, line 3 or 4? Well, what is the difference? This has a concrete class and this has a interface type, right? So even though database implements iDatabase, right? But it's this is a concrete class, right? So meaning that, let's say I have another type of class that implements iDatabase, this code will not work, right? Line 4 is only limited to this type called database, which is concrete. But if I have this class, not line number 3, right? Then any object that implements iDatabase could be used. So which one is more general, right? Line 3, right? Right, this is what we were speaking about before. We said dependency inversion, right? Remember? We should have the most general type. Well, this is an example, right? We could either use database, which is only one type, which is a concrete type, or we could use iDatabase, which is more general, right? Because many objects could implement iDatabase, right? So we're always better off using iDatabase, right? Okay. Do you understand why lines 1 and 2 are no good? Because they just don't, it doesn't make sense, right? If I want to use a database, I don't inherit from it, right? Because I'm not, accounting has nothing to do with database. It uses a database, but it doesn't, it's not, extends means it is a database, right? And implements also sort of means that, right? Means that implements actually is even worse. Implements means that all the methods in the database I have to put inside the counting class, which is ridiculous, right? Right, that's totally weird, right? So this makes sense that all the methods inside the interface have to be created in the database class. That makes sense because a database class should do everything that all the methods that iDatabase supports, right? But to say that accounting should do that is ridiculous, right? Because this is not it's an accounting class, right? It's nothing to do with database. It just uses it, but it's not implementing stuff from it, and it's not inheriting from it, right? So the best thing would be line 3, okay? Because this is the most general code, okay? Okay, think about it a little bit. You'll see what I mean. Okay, so for example, like for example, we could have, I could have um, public class, uh, SQL Server. I could have public class, um, Oracle, right? And all these different types, database, SQL Server, and Oracle, will all work with line 3, but only this one will work with line 4, right? The other ones, I would have to change the code in line 4 in order to use SQL Server or Oracle, right? This would have to change before I could use it, right? So that's what the dependency inversion says, is use the most general type so you don't have to change it later on, right? Okay? Okay. Again, this is, forget about this, just know these terms. Know the terms below. Okay, so dependable software means what? That it um meaning that, well, it's it means I could it's reliable, right? Meaning I could rely on it that it's gonna work, right? In other words, like if you go in a car that's not dependable, that means that you're only 90% sure you're going to get where you want to go, right? If you're using a really dependable car, then you're 99.9% you'll get where you're going, where you want to go, right? Usable means exactly what it says. It's easy to use, right? So for example, this code over here, this program over here is not so usable because in order to get to to the to be able to use stuff, I have to scroll all the way up, right? So the usability is a little bit uh, not too good. What was this over here? Oh, 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 yeah. We skipped that? Uh, we skipped this. What does this image below demonstrate? So remember, we said there were 6 types of relationships, right? That we did in the UML class diagram, right? So one of them is just a plain line. What does that show? Remember? I think we said 6 types. So, so the answer would be, come on, take a guess. Association, very good. Right. Plain line just shows that there's some relationship between the two. This is nothing, this is not one of them. Do you remember the other ones that there are? There's association, there's inheritance, there's association, inheritance, dependency, um, um, uh, composition, and aggregation. Is that 5 or 6? Again, inheritance, um, association, um, dependency, composition, and aggregation. Yeah, it's 5. I don't think we did any more. I seem to think we did, but I don't remember. I think that's it. Yeah, I think we just did 5. Okay, so there's 5 types, right? And they all have their own symbols. So um, I'll just Google it right really quickly to show you. So symbols um, for um, um, UML class diagram. Oh, here it is. I just passed it. Uh, oh, well, yeah, we skipped the realizations. That's 1, 2, 3, 4, 5. Yeah, that's fine. So let me just uh, um, take a picture of this so you'll see, you'll know this. And let me just go into, what's it called? Paint? I'll just paste that in and I'll take out the, this one over here. Realization. Okay, and I'm going to select all. And I'm going to copy, I think. Control C. And then we should be able to put it back into here. So let's just put this over here. So these are the 5 types, okay? So basically, this is inheritance, association is just a plain line, dependency is a dotted line. Forget about the arrows. And the aggregation shows a empty diamond and a solid diamond is composition. Okay. Okay. Usable, scalable means can grow demand. Efficient, something's efficient means that it won't, it won't, it doesn't waste resources, right? So a efficient, or like, for example, efficient sorting algorithm will sort quickly, right? It won't waste CPU time, right? Or it won't waste memory, right? Or, something like that. It doesn't waste, doesn't take up disk space or stuff like that, right? Okay, just get rid of that. Okay, maintainable, we said means easy to fix. Okay, 74, degree necessary to be a software engineer. What degree do you need? None, right? Answer is 5, none of the above. Okay. Um, it's sort of like the same degree you need to be a life coach, right? Anybody could call himself a life coach, right? There's no degree, there's no certificate, there's no, you know, there's no, it's not like a psychologist, you have to pass certain things and stuff like that, but a life coach, anybody could be a life coach, yeah. And, yeah. Okay, regarding the following, testing, operational manual, Java code, requirements documents, technical documentation, financing, which of these are part of a software project? All of them except for F, right? Because financing and hardware are not part of like advertising, hardware, that's not part of software. Okay? So the answer would be A, 1. Okay. Which process model requires software discovery? Reuse. Very good, because we're looking for stuff to reuse. Okay, and this stuff is these are based on the personal presentation, so don't worry about that. Okay, I'll just take this, get rid of this. And that is it. Okay, so we did the test. Okay, well, we did more than the test. We explained all the answers, right? Possible answers. Okay, so Sunday night we said 7 o'clock, 7 p.m. And I hope to continue and I'll record it. So, okay, I'll see you. Have a good weekend. And to start, well, all I'm going to do is go through all the folders on the website. Okay, I'm just going to go through all of them. So you could do the same thing without me.
Exam is
What?
Exam is mostly multiple choice.
Mostly, it's very similar to this. Yeah. This is an old test. I wasn't so good at the time writing tests. I don't know if I'm better, but I think I am. Okay, so hey, have a good weekend, everyone, and stay warm. Yes. Is this supposed to rain?